We all know that persistence tends to pay dividends eventually, but in the data world, there's a new way of doing things: streaming. For many business uses, just streaming data without persisting at first makes sense. What are those use cases and how does it all work? Check out this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yes, indeed, yours truly, Eric Kavanaugh here. Wrapping up year 15. Well, we're going to turn 15 in February of this coming year. So year 16 of DM Radio is on the docket. We have just rolled out the editorial calendar. So if you want to be on this show in 2023, send me an email, info@dmradio.biz. That comes right to me. We'll be talking all things analytics, big data, cloud, digital transformation, all this fun stuff, and really how it can help you. That's the bottom line. How can you use these technologies to get access to your data, to analyze your data, to leverage your data, to get your data faster, to get your data into new applications, to have analytic-driven applications. And today, we're going to talk about one of the hottest topics in the industry, quite frankly, and it's streaming data. So we'll talk about Apache Kafka and technologies like Zookeeper and how it might be getting replaced, apparently, which is kind of interesting. We'll also talk about data movement technologies. We've got two great guests lined up for you, Gary Hugmiller from Archeon, and we have Paul Brebner from NetApp, actually via Instacluster, via Spot, as I understand. So we'll be talking to those gentlemen. And so what is streaming data? Well, very quickly, Apache Kafka, it came out of LinkedIn. So the engine that actually runs LinkedIn, that makes all these connections, allows you, it's basically a distributed messaging system, if you get right down to it. It's a streaming data system. And LinkedIn open sourced it. Gosh, I guess about 10 or 11 years ago, maybe even 12 years ago now, if my memory serves me correctly. And it has been a significant game changer. Now you ask yourself, well, what does streaming data mean? Well, traditionally you would bring data in from some web front end or some kind of system, point of sale system, and then it gets persisted into a database. In the old days, there was Oracle and DB2 from IBM. Microsoft, of course, came along with their technology, SQL Server. You had Access databases, lots of different databases where you'd store the data, and then your applications would reach in and grab that data as needed to do their transactions. Well, streaming data takes a slightly different approach. Streaming data allows you to pull topics in, as they call it in the Kafka world, to basically subscribe to topics and get data immediately. So what does this do? There are lots of interesting applications, but when I interviewed Jay Krebs back in 2014, I want to say, we were talking about what this really means, and I likened the streaming data architecture to kind of like the interstate highway system of the US. You can still go on your local roads, for example, even like High Route 66, these older highways, it's just going to take you a lot longer. But the interstate highway is sort of adjacent to, and in many cases up above, the traditional road system. Now, the kicker is, how do you get the clover leaves? How do you get the on-ramps and the off-ramps to take this sort of stuff and integrate it with your existing environments? And that has been one of the challenges, quite frankly, is to figure out how to do that. And I think for that reason, you have a lot of really net new use cases that are coming along for the streaming data. But if you just think about it, there are all sorts of applications. If you get data coming in, you want to feed it to your marketing team, to your sales team, to your operations team. Well, you just set up topics and they all subscribe to it. Now you don't have to worry about the sort of traditional way of moving data all around, which was always ETL in the old days: extract, transform, load. So our guests today are going to tell us a bit about all that, what they're doing, and how it changes the game. So maybe I'll first throw it over to Gary Hugmiller from Archeon. Gary, tell us a bit about yourself, your company, and how you're using this technology to change and improve business.
Yeah, great, Eric. Look, awesome to be with you here, and thanks for having me on the show. So my background, I've been in technology for, 20 or 25 years or so. All of it selling stuff to enterprises. The last 10 years or so was spent selling large machine learning and AI-based applications to banks, insurance companies, government agencies, that sort of stuff. And the stuff that we would wind up building for these organizations would be these very comprehensive models that every single one of my customers always wanted to have fed with real-time information, right? Because we were tackling things like fraud and security, next best action, and all that sort of stuff, right? none of these guys could ever get it in anywhere close to real time. Most of them were getting batch refreshes that would occur, let's say every 2 weeks or so, or maybe a month or so. And then the secondary problem would be that once they got a refresh, right, things would change, right? Somebody would change a field type, or add a new thing, or change a thing, and so the models would break, right? And so then there'd be this mad scramble to run around. And so, what struck me as being a large market driver right now was the fact that, like, this world of AI and real time and machine learning and all the apps and stuff that go along with it was a real strong pull, without a lot of great solutions, right? And invariably, the solution that we do is we provide access to those transactional data stores, like you mentioned, like the Oracles, the DB2s, or whatnot, where really the lifeblood still of the company's interactions with customers occur. And we allow those things to kind of move up to, either Kafka, or directly into cloud data warehouses or other things like that, in a way that is transactionally consistent, right? So everything in the proper order. It only shows up once, never shows up more than once. And in real time and everything else like that, right? And so, by also ensuring that any of the changes that I noted earlier are kind of documented and dealt with in a way that's elegant versus just breaking everything, right, is really starting to add a lot of value to the customers we see, moving into this next generation data modern sort of architecture that everybody's driving at.
Yeah, this is, and just to explain to our audience, change data capture, this is a very old technology that is getting a lot of new attention these days for lots of good reasons. And basically what it says is, I'm only going to move data that has changed from this source system. Again, this is opposed to the traditional way of ETL, where you would grab a whole bunch of customer data and then boom, move it over to this other place. And with CDC, you're just tracking changes in one system and then moving only the changes over to the new system as needed. Isn't that right?
Yeah, that's precisely right. And there's one other attribute of it that's super important, and that is the fact that we don't actually tap into those source systems themselves. We basically read the logs. That's kind of the beauty of change data capture. You're reading the logs, the write ahead or whatever logs that these systems actually have. The technology we've developed has done it in an agentless sort of way, so you're not installing anything on those source systems, which, by the way, was a reason why a lot of those old customers of mine would only be able to get batch data, is because the DBAs wouldn't want people dinking around in source systems on a regular basis. So exactly. So change data capture solves all that problem, right? We read the logs, so we're secure. We're not taking down the system. We're not doing other things that could be problematic. As you noted, we move only the change, and we do it in real time, right? And the other trick that is modern to how we do it, there's a lot of like architectural choices on, little microservice sorts of things that we're doing, or the ability to kind of have a cloud infrastructure sort of stuff, so you can do things like, work on, spot instances, because like coming down, like spot instances might sometimes come down and that sort of stuff. So you need an ability to kind of transition gracefully in order to keep that CDC real-time pipe working. And so those are a lot of the cool and new things that we've added to the technology base. But at the end of the day, you're right. It's basically about persisting data from one source to the other in an elegant way.
Yeah, and managing state, right? Isn't that kind of what it's doing as well? Because one of the interesting things about this new modern data stack that people keep talking about, and cloud native in general, is that we really sacrificed state for the purpose of scale, right? So we wanted to achieve scale. And so in doing so, we kind of said, okay, we're going to worry about you later. We're just going to scale this out. So now you have this whole set of other challenges to deal with. And I think it all works out. You have a net gain at the end. But nonetheless, it is a different challenge, right?
No, you're absolutely right. And that whole state thing is super important. Like, for example, if you're going to power real-time applications, maintaining that state is actually the most important thing, right? Because if you don't have the proper order of transactions or anything else like that, you get really weird. Think of a trading application, right? Let's say you built some sort of a trading app on, a cloud warehouse of some sort, right? You need those transactions to show up in the exact order that they showed up originally. Otherwise, you're going to wind up in a situation where you may be trading on something old, right? And that's a recipe for disaster. And that's one example, but it's true across almost any number of the real-time use cases. Is they have to be in the proper state, and obviously show up there timely.
Yeah, no, that's a very good point. And you're also kind of serving as a bridge is the
Yeah.
way I look at it, right? Because I talked about these clover leaves
Mhm.
in the analogy to the highway system, and I think that's kind of where you're sitting, right? Is you're
Yeah.
managing, you're watching the log files of these various operational systems and then porting over the changes as they come along. They get into a message queue basically, and that
Yeah.
message queue points at the cloud or points at the other system wherever it is. But in
Yeah.
doing so, you're allowing for data to move very quickly to get where it needs to get and to
Yeah.
enable the business processes that it underpins, right?
Yeah, so the way we think about it internally is that what we're really trying to do is get to a world where we're building this data availability as a service, right? So
Mm.
in the modern world, whether or not you're building something on Kafka or whether or not you're doing it on, some sort of native form on a warehouse, the applications that or I'm sorry, the platforms upon which you'll build those applications or machine learning models or whatever else, the modern data architecture says you build them on the form of that is best suited for the need you're trying to solve, right? And so what
Mhm.
that means is that, okay, so now I'm going to go and adopt a data warehouse that's got a real-time capability because I've got this, very, sophisticated, time-sensitive sort of thing I want to build, or, I'm going to go build some machine learning, so I'm going to do that on Databricks or whatever else. Gone is the world, I think, that you are constrained to deal in the environment that your IT group gives you, right? Like, hey, this is our, whatever Teradata thing, and that's all you're going to build on, right? Then the new world is like, you're going to go and, get a license or a login or whatever to the warehouse you want. And then you need to be able to get that data quickly and effectively. Otherwise, if you don't do that, right, you're going to spend a lot of your time figuring out how to put the plumbing into place. So to think, the clover leaves and the highway that you're talking about here, versus actually, doing something valuable like, building the app, testing the app, confirming that it works for the purpose that it's built for, and all that sort of stuff. And so I think the modern data architecture basically has to emphasize that availability aspect. Otherwise, it's kind of going to be a non-starter going forward, and that's really what we did.
Yeah, that's very interesting. It's a very good explanation too. And you're right, in the data business, we've spent a lot of time and effort kind of patching the way we did things initially.
Yeah.
And I've heard a lot of jokes about it over the years of, putting Band-Aids around things and then Band-Aids
Yep.
on Band-Aids and then coming up with all these solutions. And what's interesting about streaming data, I'll throw this over to you and then I'll bring in our other guest here in a second,
Yeah.
is that streaming does offer a whole new way of doing things, right? I mean, it is a fundamentally different architecture.
Yep.
And that was kind of the challenge I was referring to of kind of patching that into your real-time environments. But what do you think about this chance to revisit how we do things and how streaming has enabled that?
Oh, you're spot on. I mean, like, so right now, I think gone are the days where we have to figure out, the simplified, business intelligence sorts of things and stuff like that, right? Those have been solved relatively well. They'll continue to iterate on it, but I think those things have been solved. I think what's happening now is this realization that there is so much more value to be gleaned out of the data that's coming through these transactional systems or other places, right? But the value of that data diminishes as time goes on, right? And so this ability to go off and capture it as close to the moment that the data is generated is really what's kind of driving this. But to do that, to address your point clearly, the way that we talk about it is like, look, if you're building a modern data architecture, you need to be looking at modern data tools and technologies and not basically trying to go and take this thing that's been working for 20 years and twist it and duct tape it and put baling wire on it and hope it works out, right? Because it won't, and your competitors won't be satisfied with that either. So this is a challenge for everybody to rethink what they actually need and make the right choices.
Let's bring in our other guest we've got here, Paul Rebner from NetApp. Paul, tell us a bit about yourself and what you're doing in the new age of streaming data.
Hi, sure. Paul here from Canberra in Australia. Thanks very much for the invitation back on the show again. I think it was almost the same time last year that
That's right.
was
Good
doing
memory.
this. A fun experience. So thank you for the opportunity again. So I'm the technology evangelist, the open source technology evangelist for Instacluster. We were acquired by NetApp earlier in the year, so we've been having a fun year integrating with NetApp and potentially discovering some quite interesting and challenging use cases from existing NetApp customers, and hopefully working with some of them in the future, coming up with some more interesting use cases for some of our managed open source technologies. So we provide managed Cassandra, that was our first technology. Second one was managed Kafka, and we've added quite a few new technologies over the years. So I just sort of, based on the topic of this the show, I thought I'd just briefly talk about Apache Kafka and how it relates to persistence, because Kafka is a streaming data platform. So what does it have anything to do with persistence at all? It's a distributed platform. It's a pub-sub system for streaming data from producers to consumers via topics and Kafka brokers. It's great for low latency, high volume applications, but I mean, does it use or work with persistent data? And the answer is yes to both of those. Internally, it persists messages on disks on the brokers themselves for data durability, so you don't lose any messages. For replication, to ensure high availability and fault tolerance, and for fan out for delivery of the same message to multiple consumer groups, and for replaying events. So this is one of the superpowers that I really like Kafka for. So it's got many use cases, this ability to replay the same messages over and over. AI and machine learning is one. You may want to reuse the same data multiple times for training different machine learning models, for examples. So the messages are retained by Kafka in the brokers on disk for as long as you like. So that in a sense, Kafka is a persistent architecture, fundamentally under the hood. But in terms of how you use Kafka, Kafka is often used to build microservices, and some of these often use a persistent backing store. PostgreSQL and Cassandra are two that I've used for that. A couple of years ago, I built a demo application to do anomaly detection in Kafka using Cassandra as the backing store. And this is a good use case because it has to be real time. You want anomalies to be detected as quickly as you can, but you actually need to be able to look at the stateful historical data as well to do that. Kafka Streams API is one of the more powerful Kafka APIs that allows you to build powerful streaming applications to combine data from multiple topics and create new data streams with new information in real time. And they actually have something called a state store. So it's basically a type of database which computes the state from the events coming in and allows them queries on from the stream applications. So state is created from event streams using event sourcing. And again, a few years ago, I built an application in the IoT logistics space to compute truck weights for deliveries and make sure that trucks are not overloaded at all. Cadence is a workflow engine. It's good for orchestrating sort of sequenced steps, stateful sequenced events that can be scheduled for a particular time, and also that are potentially long running. So at one level, it's quite different to streaming data, but it's highly scalable and fault tolerant. But under the hood, again, it actually uses what I mentioned before for Kafka. It actually uses event sourcing to achieve both of those things, similar to the Kafka Stream state stores. So the state is actually written into a database, and if something goes wrong with the workflow, it'll actually reconstruct the state of the workflow by reading the data back again from the database. So it's quite straightforward. It's actually very much like the CDC type systems as well. At that point, you're turning an event stream into state, and the two ideas are interchangeable in a sense. So I mean that the drone delivery problem basically involves a lot of steps. You want to get drones from their starting point to pick up things from where the shop is and then get them delivered correctly. It's got to do movement calculation to get from one location to the next. There's a lot of quite heavy maths involved in doing the flight calculation. And you want to make sure that if something goes wrong, the drone doesn't sort of just drop out of the sky or get lost. They actually have enough problems in real life with bird attacks attacking drones. So
I can imagine.
I was able to model the whole drone workflow system as a bunch of Cadence workflows. I used workflows for the drone part of the story and also for the order part of the story, and the workflows communicate with each other. But in terms of the Kafka part of the story, essentially I wanted to introduce some event-driven complexity into it. Basically, once someone places an order on their app, that results in an event being delivered to Kafka, which is then used to trigger the start of an order workflow in Cadence. So that's pretty straightforward. But the more complicated bit of the story, which is hard to explain without a picture, but I'll try, is that you need a matching service, basically. There's drones and orders. So you have to be able to match a drone to an order that's ready to be collected. And the way I did that was essentially build a new Kafka microservice that takes in events around whether drones are ready and whether orders are ready, and matches them together, and then sends a message back to the Cadence workflow that is managing the drones saying, hey, you've got an order ready to pick up at this location, fly there, go get it, and deliver it to a certain address. So that was sort of a fun complication. So it enabled me to combine essentially the sort of orchestration style architecture that workflow systems have with the choreography type event streaming system that Kafka provides. So there's the merging, if you like, of two architectural styles working together to build a really fairly complicated application. And it worked really well. It was pretty successful. We were able to run about 2,000 simulated, I should point out, not real drones flying at once, doing all these deliveries, going at 100 kilometers an hour. In fact, it was so realistic when I was showing it on a map to one of my colleagues. He said, did you actually get a drone flying license? Because you realize you have to have a license in Canberra to fly drones commercially.
Oh, really?
And he actually thought I'd actually built a real drone delivery service. I thought that.
Well, life imitates art, and art imitates life, right?
Exactly.
That is really, really cool stuff. And, as we're talking about this, I'm thinking about why we're seeing this just remarkable change in how to build applications, how to get things done in the world. And I'll throw it back over to Gary, maybe to comment on this. What Paul was just discussing here, this way of using these workflow engines that will sort of complement each other and talk to each other. It's very, very interesting. It's much more dynamic. And if you think about, like, let's talk about soccer for a second, football, as most people call it around the world. You see these teams that play very, very well together because they're teams and they practiced and they played together many, many, many times, and they're very talented. And that's why you've got a Lionel Messi who can just pull this pivot move in the box and just pop, kick it over to his buddy who goes bam and drills it in, because you're all moving to different places at different times, right? So if you were to try to pull that off from the old world sort of monolithic software architecture perspective, it would be very difficult and it would be very taxing, and you probably would never even get there, right? Just because of the constraints of the system, of the sort of up, down, from the app all the way through the operating system and all the way back up to the app and back down the operating system and all the way back up to the app. And these new environments are designed to be much more modular and dynamic. And as such, I think they're also more durable and more efficient. But you have to do them correctly, of course, but I think that's what's happening in the world of applications. What do you think, Gary?
Oh, it's absolutely what's happening here. So I think you see it in the diversity of the platforms upon which people build things, and the diversity of the tools that they use to build those things, the way in which they power them or bring data to them, and all of that sort of stuff, right? So, and that's really kind of, at the end of the day, what I think this modern data world is really evolving into, right? Which is a world of, a very high degree of flexibility and ability to innovate using a variety of different tools. Now, it does create a problem, right? And the problem is that you could wind up in a space where the amount of technical diversity out there is almost infinite, right? And then you have a management problem where, if the one person who built this thing on that platform decides that he or she's going to go get a different job, right? Suddenly you're hosed, right? Or a variety of other sorts of circumstances like that. But there's definitely an element to this modern data world that we're moving into where, trial and error and different places upon which to do things is more the order of the day versus, like you said, the old, monolithic applications that, you will use this data space and you will use this, interface and that sort of stuff, which simply doesn't fit, right? And I think the reason it doesn't fit is because there are so many different influences on the applications and things being built. To take the Uber example that Paul talked about before, think about that, right? The reason why people have a low tolerance right now for those monolithic data application sorts of things you're talking about is because they've had experiences like, DoorDash or Uber or other things where, they're like, hey, this is pretty good, right? Somebody's really thought through how to get this working, and I'm not going to go back to, hailing a taxi cab on the street corner and, giving them a $20 bill when I get out of that thing, right? And so those are the things that are basically driving all this innovation, is because people realize, well, it's possible.
Yeah. No, that's exactly right. And so now we're seeing new business models built on top of these, right? You have new business models carving out their various niches and doing business in a more efficient way. And I think we're on the front end now. And I look at recent events in the geopolitical world, that have big impact on us. Of course, the war in Ukraine affecting prices, affecting supply chains, etc. Now you have this recession that has come on pretty strong, pretty quickly. And so what's happening to me, this is a sort of grand forcing function coming together, and it's just going to squeeze out the old ways of doing business. You're just not going to be able to survive unless you adapt and do things in a new way. What do you think, Gary?
Yeah, so I have a lot of theories on that one. So number one, I think the changes in the world and your ability to react to them, it's becoming an ever faster sort of requirement that we take advantage of the opportunities or figure out how to blunt the risks that are thrust at us, either from global events or from changes, even in customer dynamics, right? I mean, if suddenly people are buying blue things, then they shift to green, right? You want to be able to catch up with the green thing pretty quickly. I'd posit this other sort of thing and this comes from a couple of years of working with customers who were working on very advanced sort of machine learning. And now my customer set here, where everybody's basically thinking about how do I get into this modern data architecture. The observation that I had or have is that you're going to have to modernize, full stop, right? There's no choice to it, right? Because, if you don't modernize, right, your competitor will, right? And your customers will also get this sense that you're a clunky old shop, right? And nobody wants to go do business with a clunky old shop. There's one other further compounding effect on all of this, and that is the fact that if you are late in modernizing, not to scare people, but it'll get exponentially harder to catch up because the advantages that are going to have been built in by the people who modernized early and have realized, I could iterate faster, my supply chains are more effective, my customers are happier, right? It's going to get exponentially harder over time to catch up. So it is kind of an imperative for every, CEO and CIO out there to ask of their infrastructure, am I operating in a world where I'm the most modern possible? And am I setting myself up for success by leveraging the tools out there that allow me to be the most nimble I possibly can be?
Yeah, that's a really good point. And maybe I'll get Paul to comment on that. Agility is going to be absolutely mission critical in this coming year. I mean, we're a small company and I see it affecting us in our ways. I see social media affecting the behavior of people. I see the pandemic, which led to everyone and their grandmother doing webinars, and that's been a core part of our business for years. So a lot of these things are fundamentally changing, and as a small business, we have to adapt. Now we're small, so we can do that pretty easily, but larger organizations, I mean, you have to find a way to instill an appreciation for the changing dynamics in order for your teams to survive. What do you think, Paul?
Oh yeah, absolutely. I mean, there's certainly lots of use cases around that, and this relates back to what I was talking about with the change in Kafka. If I can briefly talk about that, maybe. So, so even Kafka itself as an architecture actually is subject to some of these demands and potential changes as well. So I mean, for a long time, ever since it was invented, Kafka's actually relied on a third-party external store for its metadata and for coordinating the actual Kafka distributed system itself, and that's Zookeeper. So that Apache Zookeeper was another Apache project, and that's worked pretty well for more than 10 years, but it does introduce added cost and complexity having to run that third-party persistent storage service. So they've been thinking for quite a while about trying to replace it, and also for benefits of scalability and speed as well, potentially, because the Kafka Zookeeper service itself does introduce some extra latency, and it's got limited capacity in terms of scalability.
Yeah,
it's actually limiting the Kafka cluster itself potentially. So this year, Kafka's had essentially a brain transplant. So there's a new internal protocol called KRAFT, the Kafka Raft protocol. It's basically replaced Zookeeper now for metadata management and broker election. So KRAFT actually uses Kafka itself for the metadata storage. So I was talking about the fact that Kafka actually persists all the messages. So they're actually utilizing that fact to be able to store data about Kafka in Kafka itself. So it's going to be a lot more faster, scalable, cheaper, and easier to manage, and reduce the complexity of running the Kafka system